what if factor t's are not your preference? What if trying to remember all of the factors for all of the numbers is too difficult? Well, then perhaps you'll use something called factor trees, which you know about. If you remember, factor trees are what you do to get the prime factorization of numbers. So, we're going to use these prime factorizations, and we are going to use a Venn diagram to help us figure out the greatest common factor. Okay, so a Venn diagram has two circles, and in the middle is what they have in common. And in the middle of this is where we're going to find common factors. So 16 and 24. The only thing that you are needing to pay attention to is what are the prime numbers. So which numbers would you have circled? So on this one I would have circled a 2, a 2, a 2, and 2. And over here I would have circled 3 2s and a 3. And now it's just a matter of looking at what you have in common. So because this one is here and this one is here, I'm going to put a 2 in the middle. Now I'm going to take this 2 and this 2, and it's kind of like we're moving them to the middle. And then here's another 2 and another 2, and this one has a leftover 2 and this one has a leftover 3. So when you're looking at the circle, you see that inside this circle, which represented 16, there is 4 2s. And in this circle, which represented 24, there is 3 2s and a 3, which matches what we have here. So the greatest common factor is 2 times 2 times 2, which is 8. 42 and 24. I'm going to just simply erase this, make another Venn diagram, and identify what numbers are in 42 and what are in 24. 24 again is a 2 and a 2 and a 2 and a 3, and 42 is a 2 and a 3 and a 7. And so now I'm going to identify what they have in common and move the common ones to the middle. So this 2 and this 2 will join together and end up here. And this 3 and this 3 will end up here. I have a leftover 7, and over here I have a leftover 2 and 2. So now I can check it by looking inside this circle. 2 and 3 and 7 really do make 42. And over here, 2 and 2 and 2 and 3 really do make 24. So the greatest common factor is the 2 and the 3. 2 times 3, which is 6. Finally, 21 and 42. Now on this one, we have the 2 and the 3 and the 7. And the 21, we have the 3 and the 7. So the 3 and the 7 are what show up in both rows. So the 3 and the 7 go here, and this one is there. There's nothing left inside this circle, but you can see this circle is still 3 times 7, which is 21. So the greatest common factor is 3 times 7, which is 21. Two ways, a factor T or a factor tree with the Venn diagram. And we're going to take it one step further, and we're going to make this a triple diagram, which means we still have the common area, and we're going to do the exact same thing, except we're going to have 3 trees. Now, when I do a tree for 12, we'll put 12 on this, and I get a 2 and a 2 and a 3. When I do a tree for 20, I get a 2 and a 2 and a 5. And then when I do the tree for 24, I just did it on that last screen, and I got a 2 and a 2 and a 2 and a 3. Now we're looking for what all of them have in common, and we're going to take it from each line and put it directly in the center. So I'm looking at a 2 and a 2 and a 2. I'm going to take a 2 from each line and put it the center. And now I have a 2 and a 2 and a 2. I have another set that I can put in the center. This one has a 5. I don't have any 5s that this shares with, so the 5 is going to just simply go in the 20 circle. 12, I have a 3. I also have a 3 here for 24. So I'm going to take the 3 and share it between the purple circle and the green circle. And then I'm left with a 2, and there's no other 2s, so it goes here. Now, for greatest common factor, the only thing that you should worry about is the very center, and 2 times 2 is 4. So the GCF of these three numbers is 4. Now, this is the same kind of thing, except it's asking you to figure out the numbers that go here. And it told you that the GCF is 4, and we see that because 2 times 2 is 4. So they're asking you what numbers are in this circle and what numbers are in this circle. Well, if I look at the red, I've got a 2 and a 2 and a 3. If that's the prime factorization of a number, what number is it? Well, we know that if you multiply the prime factorization, you get your original number. So 2 times 2 times 3 is 12. Over here, I've got 2 and 2 and 5. And 2 times 2 times 5 is 20. So this problem is talking about 12 and 20.